Hey guys, welcome back to another video, and today we're going to be solving the Leet code question, longest substring without repeating characters. Alright, so in this question we're going to be given a string s, and we want to find the length of the longest substring without any repeating characters. So the question itself is pretty simple to understand, and let's just look at an example. So over here, we're given this string over here, which is ABC, ABC, BB. So I'm pretty sure you could just look at it and understand that the longest character that we're going to get without any repeating characters is going to be ABC. So you could either get that from over here, so that ABC, or this ABC right over there. Now let's just take an example, and let's say we take ABCBB. B. So in that case, we would have two B's. There's a repetition of characters. Another example is, let's say we take CABC. Again, there's another repetition of characters in that case as well. So I'm pretty sure you understand what the basic idea is and how exactly can we solve this question. So a pretty simple or brute force type of approach would be to have two for loops, and what you would do is, so you would consider each letter to be the starting letter, right? So in this case, what we would do in the first time, we would consider A to be our starting letter, and we would build up whatever the largest string is possible without any repeating characters. So in this case, we would do A, B, C. Okay, so then we would have an answer, which is 3, and we're just going to store it somewhere. Now, the next iteration, we're going to consider B to be our starting point, and from B, we're going to start off, we're going to try to find what is the largest substring. So that's going to be a big O of n squared solution, and we can obviously do better than that. So the other solution, which is a big O of n time complexity solution, is going to be using the sliding window technique. So if you don't know what that is, it's actually pretty intuitive, and it's pretty easy to understand. So let's just kind of try to understand it using this example over here. So, I will be going into it in more depth, but for now, let's just try to do it like this. So in this case, let's say I'm iterating over my letters over here, and I want to find the longest substring. So let's say currently my longest substring is just letter A. Then I'm going to increase it by one more, and now I would have the letter B as well. So now my longest substring is AB, and again, I do not have any repeating characters. So now let's say I increase it one more. Now I have a length of 3. So my largest substring has a length of 3, and that's good. But now, once I increase the length to it by one more, with a length of 4, I have the character A. So what this is telling me is that the character A is now getting repeated. So now the question is, how exactly can I change my array in such a way that I do not have any repeating character A? So there's two ways to go about that. One is to, well, ignore this A, or the other is to include ignore the first A. And that's what we're going to end up doing, because we want to look at all the further possibilities in the further on into our string. So in this case, we're going to get rid of this A, and we're going to look at everything past that. So B, C, and A. So I'm pretty sure it's pretty easy to understand, and let's just do it one last time. So B, C, and A, and then after that, I would add another value, which is B. So when I add the value B, what's going to end up happening is, well, B's end up getting repeated again. So in this case, now I'm going to make my string, or my substring, to just be the values C, A, and B. And then again, that happens with C again. And each time we're going to keep doing that. So it's going to have a time complexity of big O of n, since we're only going to be going through the array one time. And we're going to be finding the largest substring possible without any repeating characters in that time. So using the same concept and just with a more detailed explanation, let's see how that works. So the basic idea over here is we're going to have two pointers, okay? So I'll just call them I and J. Okay, so think of I as our starting pointer and J as the ending pointer per se, okay? And another thing that we're going to have is a dictionary, okay? So this dictionary over here is going to be used to store the letter. So we're going to have our character and the index that we found it at. So the purpose of this, I'll try to explain it as we're going along. And it should be really simple to understand. Okay, so we start off with our I and J pointers at the 0th index, okay? So basically, our substring is going to be whatever is in between of I and J. So as it is, there's nothing in our substring. Okay, so what we're going to do now is we're going to move J to the right by one. So now in this case, before we actually do that, what's going to happen is we're going to check for the letter A. So is the letter A inside of our dictionary? Well, it's not. So in that case, we're going to add it to our dictionary. So we're going to add the letter A. And what is the index that we found it at going to be? So the index we found A at is at the 0th index. So let's write down 0. Okay. So now we have a B. So that's our substring. And as you can see, there's no repeating characters. So in this case, what we do, we go to J, whatever character is at J, and we add that to our dictionary since it's not already there. So B, and then it's at the index 1. Okay, I'll just go through this a little bit faster now. So now we go to C, and again, is C inside our dictionary? Well, it's not. So that means we've never encountered C. So we're going to have C and then index 2. And same thing for D, and D is going to be at an index of 3. So J was supposed to be here. Now we move J again. So finally we have E, and E is at an index 4. But now let's see what ends up happening. So what ends up happening is we're going to move J over here. And now J is at the letter A. Now the problem is we have the letter A 2 times in our substring as it is currently. So like I showed you earlier, what we're going to do is we want to move the I pointer, right? Because we want to keep moving our J to the right to see all possibilities. So in this case, how exactly are we going to move our I pointer? So just by looking at it, what we would do is we would look at where was the last time we found the letter A. So the last time we found the letter A was at the 0th index. So now to move our I pointer, we're just going to move it 1 to the right of it. Okay. Now let's do the same thing, but let's talk about how our dictionary comes into play. So the dictionary is storing where we found the certain character at which index we found it. So in this case, it's telling us we found the character A at the index 0. So what that basically tells us is we want to move our I pointer. So since we came across A over here, we want to move our I pointer to where we found the last A plus 1. So we found the last A at the 0th index. So we wanted to move it to 0 plus 1, which is 1. So we're now going to move it to the first index. So it's going to be right over here at the first index. Okay, and one more thing that is going to happen is over here, we're going to update the value of the character A. So the character A is currently at which index? So 0, 1, 2, 3, 4, 5. So it's currently at the 5th index, and that's what we're going to store over here. So just one last time, we previously found the value A at the 0th index, but since we came across it again, we're going to move our I pointer to the right of the last time we encountered the character A, which in this case is going to be 0 plus 1. So we're now going to move it to the first index, and simultaneously, we're going to change or update our A value because now the last time we found A is going to be at this index over here, which again is at the 0, 1, 2, 3, 4, 5, 5th index, okay? So just to make it easier, I'm just going to write the index numbers up top. And one more thing I do want to actually add, which I forgot to do so earlier, is we're going to be storing our result over here. So let's just call it res. And what is res going to be? So res is going to be the length of our longest possible substring. So how exactly do we get this result? So let's just go back one step. And at this step, what we had was I was over here and J was over here. So at each time, we would be updating our result. Now, we would be updating our result. We would be comparing it with the old value of result. So let's just say we're starting it off with the value of 0 with whatever the new value is. Now, how exactly do we get the new value? So for getting the new value, we would take the J index. So this would be whatever J is at. And obviously, J is going to be further away from I or equal to I, okay? We want to see how far away it's from the beginning. So now the beginning over here is going to be represented by the I index. So J minus I. In this case, we would be doing 4 minus 0. So we get a value of 4. So let's just see if that's actually correct. So we have a length of 1, 2, 3, and 4. But one thing you want to consider is that we want to consider the letters itself, right? So we want to consider where the pointer is as well. So what we're going to do is we're going to do J minus I plus 1. So each time we're going to be taking the maximum between the previous value and the current value, which we get by calculating this. So in this case, as it is, it's going to have a value of 4 minus 0 plus 1. Which is nothing else but 5. So that is going to be our result as it is. Okay, now let's keep going and see if our result gets any bigger. So we saw what the next iteration is going to be. The I comes over here and J moves over there. Perfect. So now when we keep going down this, so J is going to now be over here. And since F is not in our dictionary, we're going to update it. So F, and we're going to add its index, which is 6. Okay, now in this case, what is the result going to be? So the result is going to be 6 minus 1, which is 5, plus 1. So we have a value of 6 by using this. So the previous value was 5, and now we have a value of 6. So we're going to end up choosing the bigger value, which is, well, 6. So now our result is going to be equal to 6. Okay, so now we move J, and let's just go through this real fast. So in this case, B already exists in our dictionary. So that means we want to move the I pointer. Now we're going to move our I pointer to whatever index we last saw it at, which is at the first index in this case, plus 1. So now I is going to be at the second index over here. Okay, perfect. And another thing that we want to make sure of is over here. So we want to update our dictionary value over here. So B is now going to be at the index of 7. Since we're not considering this anymore. Sorry, this is supposed to be I. Okay, so we have I over here. And again, we're going to find out what the result is. So 7 minus 2, that's 5 plus 1, 6. So it's going to stay the same. Okay, so now we move J to the right again. So now it's going to be at D, and D already exists. So the same thing's going to happen. So it was last seen at the index 3. So we're going to move I to the index 4 over here. And J is going to stay as is. And this value is now going to get updated to a value of 8. Okay, perfect. So now in this case, let's find out what the length is. So the length is going to be 8 minus 4 plus 1, which is nothing else but 4 plus 1, 5. And 5 is less than 6, so we don't do anything. Okay, so now let's just go through it a little bit more quicker. So we move J. G is not in our dictionary, so let's add it with the index, which is in this case 9. Then we go to C. So now in this case, C is in our dictionary. So over here, we actually have a pretty important thing that we want to notice. Now, so if we go to C in our dictionary, it tells us that C was last seen at the second index, and that's correct. But what you also want to notice is, as it is, inside of the substring, and again, the substring is defined between I and J, which is right over here, there is no C value. So over here, when we're moving our I pointer, so I is going to be the maximum between whatever value it's currently at, so the current I value, and whatever value we get from our dictionary plus 1, okay? So let me just kind of explain that one last time. So basically, in this case, our I value is 4, but we know C already exists, so we go to C, and it's telling us to move our I index to the third value over here. Now, there's a huge problem if we move backwards. So if we move I backwards, well, one simple problem that would happen is D would now end up getting repeated. So we don't want to move our I value backwards. So we're going to choose the maximum between 4, and in this case, it's going to be 2 plus 1, which is 3. So we end up choosing the maximum, which in this case is going to be 4. So this is going to end up solving, this is going to solve the problem when we have a situation like this where we might have to move backwards. So in that case, we choose the maximum I value. So I stays as it is. So over here, again, find the result, which is 10 minus 4, 6 plus 1. So our result is now 7, right? So 7 is greater than 6, so we now update it. Okay, so let's just do this for the last 2 more iterations. So J moves over here. So now in this case, it's for the B. Again, same thing. B was last seen at an index of 7. So in this case, what's going to end up happening is I moves over here. So it's going to be 7 plus 1, and I is going to move to the index 8. And simultaneously, we're going to update the value of this to be 11. Okay, perfect. So now we find the length, and obviously the length is going to be less than 7. And one last time, so we move J over here. So B already does exist at the 11th index. So what's actually going to end up happening is, since it's at 11, I is now going to move to the 12th index. And the B is now going to get updated to a value of 12. And in this case, well, the result is going to end up being 12 minus 12 plus 1, which is a length of 1, and actually we don't really need to do anything. So the result in this case is now going to end up being 7, and that's what we end up outputting, and that is what the correct answer is. So that over here is the longest substring, okay? So now let's see how that looks like in code, which should be pretty simple. Okay, all right, so for the code, what we're going to do is we first need to define a few things. So the first thing we want to define is our dictionary, which is going to hold the letter and the index that it was last seen at. So that's for our dictionary, let's call it D. And the other thing we're going to have is going to be our result, which we're going to have an initial value of 0. Okay, so we had 2 pointers, which were I and J. And what we're going to do is we're first going to define I over here. So I is going to be equal to 0. And for the J, what we're going to do is we're just going to use a for loop for J itself. So to do that, we're just going to do, for J in range. And what is the range going to be? So we're going to start off at 0. And we're going to go all the way up to the very ending. So this is going to be the length of S, okay? So this is the j value, and it makes sense to use the for loop because each time we're moving j over to the right by 1. Okay, so keeping that in mind, what is the first step that we're doing? So the first step is we want to check if whatever character we're currently on is inside of our dictionary. So to do that, we're going to go to the string s, we're going to go to the index j, and check if it is inside of the dictionary d. Now, if it is inside of our dictionary, we need to move I. Okay, so we're going to do something over here, and we're going to end up moving I. But before that, let's look at the other condition. So if it's not in that, the first thing we want to do is we want to calculate our result. Now, to calculate our result over here, the basic thing that we saw is we did j minus I plus 1. Okay, that's all we're doing for calculating our result. And we want to update this result, right? So result is going to be the maximum between this new value that we have over here and the previous value that it had. So result comma that. So we're going to take the maximum between those two. Okay, so that's that. And the other thing that we want to be doing is we want to add the current character to our dictionary and update its index value. So in this case, we're going to go to our dictionary. We want to change the character. So the character is going to be, we're going to go to our string, we're going to go to the jth index, and it's now going to have a value of j because that's the index we last saw it at. Okay, so now we want to see what exactly do we do over here. So if the value is inside of our dictionary, we want to move the I value. So I is going to be equal. So the thing that we were doing is we go to our dictionary. So in this case, this is exactly what we're doing. We go to this character inside of our dictionary D, and inside of that, we're going to get a value of the last index where we saw it at. And to that value, we're going to add 1 because we're going to go 1 to the right of it. Now again, there was this one small condition where sometimes we were moving backwards. So to compensate for that condition, we're going to take the maximum of this. And sorry, one second. So we're going to take the maximum between this value over here and whatever the previous I value is. So that is all we're doing over here. And yeah, that should be it for our solution. And at the very ending over here, we're going to end up returning our result. So return res, submit it, and our code should get accepted. So finally, thanks a lot for watching, guys. Do let me know if you have any questions, and don't forget to like and subscribe. Thank you.